So in this video, I want to give a walkthrough of how to use a duplex micropayment channel contract that I provide the link for here, this tiny duplex channel. So basically what I'm going to do is create an instance of this contract, and I'm basically going to simulate a payment channel between two different accounts on my same MetaMask. Now to do this, I'm going to use the Remix browser. I'm also going to use, in order to create the signed messages, which are necessary in the payment channel, I'm going to use a bit of a hack, which is some tool that I wrote in JSFiddle. Basically, it will use the Web3 API to prompt MetaMask to sign a value, which is what I'm going to have to do to make payments using this channel. So I'll get to that in just a moment. Let me just quickly go over the parts of this contract. So I have a contract called micropayment, and it's going to have two addresses, Alice and Bob. Alice is going to be my main address, Bob is going to be my account number 2 in MetaMask. And when you call the constructor for this, you're going to pass in the Bob address as a parameter. So I've got my second address here ready to go in the deploy method, the deploy button in Remix. All right, and the Alice is just going to be taken from message sender. And whatever I provide as a balance is going to be what's the initial funding there. So I'm going to add a value that's like, this will be something like less than 1 Ether. I don't exactly even know how many zeros that is. Anyway, what I'm going to do is, I'll actually copy that value so I know how many, what that initial value is. So here, I'm going to go ahead and deploy this and then talk about it. So let me make sure I approve my MetaMask fee. Okay. All right. Now, so what else besides the constructor is in this contract? Well, basically there's an update method, and I'm going to call that in order to register whatever is the most recent state. So basically every time I send a payment from one party to another, initially basically Alice is the only one who contributed money, and so when Alice wants to pay Bob, she's going to create a signature. We'll use that signature tool to do that on a value with an increasing serial number and some amount of money to Bob. Now when it's time to finalize, basically Bob or Alice, if she's got signatures from Bob, are going to call the update method and pass in whatever is the signature for the other party. So the way that I've written this, one of the signatures, basically if you're Alice, then this if statement is going to skip over, so you're not going to have to worry about providing Alice's signature. If you're calling it as Bob, then similarly you don't have to provide the signature. So you call the update method and provide the signature on the other party. Then there's a close method and a finalize method. So the close method basically sets up the deadline. Right, and it's a pretty short deadline here actually, so we will actually have to make sure that this is, actually I want to make sure that this deadline is higher, because if it's too small it may be a little bit difficult to show it. No, never mind, I'll be okay with this deadline being only 2 blocks. Okay, anyway, once I call the close method, that's going to establish the deadline, and so after 2 blocks passes I can call finalize, and basically it will settle the channel paying some amount of money to Alice or Bob, depending on that amount. So let me see here. Also, just to check, I start with 38.310 Ether in that account, so I'll hopefully see that change a bit. Okay, so let me go check that this transaction was created, and then I'll make some example of using it. Okay, so here I've got that contract loaded, and I've already gone ahead and actually upload the source code for this through Etherscan's verified source. So I can go actually look at the code, and it sees all of the code pasted here. If I go to read the contract, I can also see, okay, the deadline is initially set to the maximum possible value. So basically, when someone goes to finalize the channel, the first thing they'll do is set the deadline smaller. I can look at, this is just a utility, we'll use that in a moment. This is showing the current block number, so I think every time I refresh this, if I refresh it every few seconds, I'll see some new block number. Is there any other state that's here? Well, I can see the address for Bob and the address for Alice. Okay, and the serial number is initially 0, so basically the serial number can only go up at this point. So let's go back to Remix and look at a couple of things. So the first thing that I can do is here, and I actually have, because this I'm running the injected Web3 version of this, I can actually see this instance. I get another view of the contract just through Remix. So I have all of these methods available here. Now what do I want to do next? So what I want to do next is simulate a payment from Alice to Bob. And so the way that I would simulate a payment from Alice to Bob is, let me get a little more view here. The way that I would simulate a payment from, and that's off screen too, so let me make sure that I can see this a little better. Let's go like this. Okay, that's hopefully a little easier to see. So what I need to do, I have this utility function here, hash amount. So basically, if I want to assign a payment to Bob, initially the amount that I've paid Bob is 0. I have some balance of whatever that, tens of thousands, whatever amount of smallest ether units I provide is, that's my balance, but my payment to Bob is 0. So if I want to send a greater payment to Bob, what I need to do is get the hash of the amount that I'm going to send Bob and the next serial number. So the way that I'm going to do this is, let's say I want to pay Bob 100 of those smallest units, 100 Wei, and I want the next serial number to be 1. I would go ahead and hit hash amount, and this is going to give me this hash. Now, in order to authorize this payment, what I have to do is actually go sign using my Alice public key, my main signature key here. I have to go sign this hash value. So to do that, I'm going to use this little signing tool. I don't know of a simpler way to do this. I just have to use it this way. I'm actually going to paste this hash in here, and I'm going to click eth_sign. Now what this eth_sign is doing is it's saying, here's the hash value. It's asking me to sign it using my main account here. That's this one. That's the corresponding one, the Alice key. Now in general, if you're just using a web app and it pops up a request to sign something like this, you really should check what exactly this is the hash of. You want to make sure that you're not making a signature on something that could be misused in some other context. But I can see that that's just the hash that I had pasted in, and I did this myself through Remix. I have the source code available. I know what it's doing. So I'm going to go ahead and sign this. Now when I sign it, what it's printing out here is, and I'm sorry this is a little convenient, but it's pasting the signature in the form of an array of bytes in the form that I can paste into Remix. So I'm doing this example in a way that just uses Remix. In reality, you would have a user interface as a web tool that does this, but I want to show that you can do it with the minimal number of parts. So what I actually have to do now is, if I wanted to go, what I could do now is, if I wanted to finalize with this method, I could paste as Bob a call to the update method that has the given amount, I think it was 100, the given serial number, which was 1, and the last argument here is the bytes of the signature for myself and the bytes of the signature for Alice. I have in this comment of the code a little example of what the illustration would look like. So basically, if I'm calling the method as Bob, then I would call this with the empty array to update it. So let me go through that. Even though this would be an off-chain payment, let me just go ahead and call the update function in a way that works. So I know that the amount that I paid was 100. I know that the serial number I gave was 1. I'm calling this method as Bob and providing a signature from Alice. So I'm just making sure I'm doing that in the right way. So I can just paste that signature there, and I'm also going to include an empty array because I'm not going to include the signature from Bob. Now actually I need to make sure that I am going to call this, so that's my Alice key. I have to use MetaMask to switch the account for this little demonstration to work. So let me go to my Bob account. All right, and now if I called the update method, this should work successfully. Let me go confirm this, and I'll look at what are the events that are triggered. So that was confirmed in a hurry there. If I go look at the events now, well, you can see that the first event that's here is the initial funding event. All right, and this initial funding event comes from this initial funding event was done during the constructor, so you can see that it set the Alice key, it set the Bob key, and initialized whatever was the value passed along to that, so some non-zero value. Now if this transaction is accepted and succeeds, yep, you can see here's another event that's now added to the log, and it's an update event. Now if I go back, the effect of the update event is that it has increased the serial number. That's the most recent state that the serial number is aware of, and that includes whatever is that balance for Bob. I guess this update just shows, yeah, sure, it parses it. So here I can see the amount to Bob, that's what the payment amount was, and I can see the serial number, which is now 1. Now what I can do is, if I wanted to keep doing additional payments, what I would keep doing is going to this hash amount as Alice, and every time I wanted to pay Bob, I would increase the serial number and I would increase the amount that I'm paying him. So now I've paid him again another 100 units, so now that's like 200 way. And when I took this hash, I would go take this hash, use a signature tool or a user interface would be doing this for me, and I would create a signature as Alice on this increasing amount. And then I would send this off-chain to Bob. Now, if Bob wanted to pay me back some money, Bob wanted to pay Alice, he would also create a signature using the same technique. Let me go increase the serial number a bunch to 5. Let me see if I can get the dispute case to go through that. So let's say that the last one that I'm going to do is this one with serial number 5. And I'm going to go through pasting that here, getting a signature on it. I'm going to copy and paste this signature so that I can use it. Okay, now before I use the signature, actually, let me go look at one more thing. If I look at read contract for the function at this point, and I scroll down to, let's see, serial number, you can see that serial number was initially 0, but now serial number has updated to 1, and amount to Bob has updated to 100. So what I'm going to do now is I am going to begin the finalize process by calling the close method. Now the effect of calling the close method is going to be to set the deadline to whatever is the current time plus 2. So as soon as this transaction is processed, we're going to see a new event, which is a deadline being set, and we're going to see the deadline field change to, where's the deadline? We're going to see this deadline field changed. Let me refresh this here and see if I can see that take place. So basically, Bob has requested to finalize, and the deadline is now set to just 2 blocks in the future. So basically now there's only 2 blocks to go, and if anyone has a better state than the one that paid 100 units to Bob, then they would need to send that as an update transaction in that time. So I'm going to see if I can pull this off by doing an update in time. I know that the update has a payment of 300 to Bob and a serial number of 5, and I'm going to paste in the signature. I'm not sure what the effect of this is. I think that what's going to happen is that the block number has already advanced, and so I've missed my time window. But let's go see what happens. So I'm going to confirm this, but I think that the deadline's already elapsed. And that's what it can tell. Okay, now that was already processed. Here you can see that there was a close event that had the effect of setting the deadline. If I go look at the transactions, I can see, yeah, so what's happened is that my attempt to call the update method with the serial number 5 has failed. And what we should be able to see happen, especially if we can step through exactly what the, is this going to let me step through what the problem was? I'm not sure if it'll let me debug and step through what the problem was. But basically at the time it called it, oh, I know how we can check for sure. So the block height here was 4597752. 7752. Let me paste this here just so I have it available. I'll just keep it in the clipboard. Now if I go look at read contract and I look at the deadline, I'll see that the deadline is 741. So 10 blocks had already gone by before I was able to call the update method. I really only had a grace period of about 2 blocks. It seems like blocks are being mined really quickly on Ropsten right now anyway. So basically I didn't call the update in time, and in fact Remix was warning me that it thought that the transaction would fail. It basically predicted the transaction would fail because of that. So anyway, right now the deadline has already elapsed. The most recent serial number that the contract is aware of is the serial number 1, and that corresponds to an amount to Bob of 100. So now all that's that's left to do, this contract's basically in the finalized state, pre-finalized, something like that. The state can't change anymore. If I call the finalized method, what it's going to do is send the remaining balance back to Alice, and it'll send the 100 Wei units to Bob. So let's go see what happens when this transaction gets processed. Here the transaction is pending. Blocks are being lined so fast, I think that this will happen really quickly. Well, looks like there it is. Yep, and so we can see that even though the second update method didn't go through, the finalized method did. And you can see here that the amount to Bob was 100. And what else can I look at? If I look at the internal methods here, you can see that this one transaction, that finalized transaction, had the effect of sending the remaining balance of the initial deposit back to Alice, and the 100 Wei, that was the one payment to Bob. So in a nutshell, those are the steps of using the duplex payment channel. I'll give you the address and this code so you can see this contract and play with it yourself. The only thing that's a little frustrating about this little demo is that it has to go use this little separate tool to generate the signatures, so it's a little bit finicky. In reality, you would have a user interface that simplifies much of that process, but that's a little walkthrough of the basic process.